So yeah, you could have also broken off a secant and then let u be secant x, and then du would be secant x tangent x. So that would work as well. So it's one of these like kind of funky problems that you actually can do a couple different ways. Other questions? Yeah, the simple ones are always the trickiest. Okay, so for that one you did integration by parts. You might get some. Did it work out for you? Like, I didn't try doing it by integration by parts. It's possible that it could work. You got the same answer. Okay, yeah. I was going to say, I could see it potentially working if you did it kind of the right way. Then it probably stuff would cancel out for you and it would be okay. So a lot of these problems, some of them you can do more than one way. Other questions? Okay, so do you just want me to do 3, or do you have a question about 3? Okay, so here's the thing. You do not need to, so for 3, so 2 things about 3. So 3, as opposed to like the review sheet and actually on the test. So when it comes time for so on the review sheet and on the test, I actually have the problems listed as like, these are improper integrals to determine whether the following improper integrals converge or diverge. 3, on this sheet, I just mixed them all up. So 3 is actually an improper integral. If you look at 3, you're looking at the integral from 0 to 3 of 1 over x minus 2 squared dx. Since this is kind of already in its simplest form, right? Like, I can't, yes, the bottom is a polynomial, but it's already factored for me, and there's not multiple factors going on. So because of that, that's like indication that like partial fractions really isn't going to get you far. You can do partial fractions. If you did partial fractions, you would end up getting a 0 for the one term, and you would just get back to the exact same fraction you started with. So this one was meant, first off, you have to break it up into 0 to 2 of 1 over x minus 2 squared dx, plus the integral from 2 to 3 of 1 over x minus 2 squared dx. And then integrating 1 over x minus 2 squared, that's just a simple u substitution, right? So the integral of 1 over x minus 2 squared dx, we can think of this as x minus 2 to the negative 2 dx. And if you let u be x minus 2, du is just going to be dx. So this is going to be the integral of u to the negative 2 du, which would be u to the negative 1 over negative 1, or negative 1 over u. And in this case, that ends up being, right, negative 1 over x minus 2. So that's what's going to end up happening here in a minute when I do the limit. So I can kind of, unlike, this is kind of similar to the one I did at the beginning of class, right? So if you look at the first piece, we're looking at the limit as b approaches, not infinity, b approaches 2 of negative 1 over x minus 2 evaluated from 0 to b. And so that's going to be the limit as b approaches 2. So negative 1 over b minus 2 minus negative 1 over 0 minus 2. So that second half there, that's just positive 1/2. So we really have the limit as b approaches 2 of negative 1 over b minus 2 plus 1/2. But this part here, as b approaches 2, and we're going, since we're on the left side, so this is kind of one of the ones I did the other day where we want to think about these as being the left side. So as I'm approaching 2 from the left, this piece here ends up going to minus infinity. So this bottom part here ends up, well, I shouldn't say, not the bottom part. The whole entire fraction ends up going towards, it's going down towards minus infinity, and then you have a negative. So basically, the entire part is that first chunk is bad, so the whole thing's going to diverge, yes. Nope, Lane, that's totally fine. In number 2, you could have easily let u be secant x, and then the derivative would be secant x tangent x, and you have that, and so yes, you would end up with secant squared x over 2 plus c. That's a totally fine answer for that problem as well. Yep. Other questions? Okay, so we viewed it as b is approaching from the left because of this. So if you think about it, I have this interval here, we're from 0 to 3, and I'm saying that 2 is the place where it's splitting. So I basically have 2 chunks. I have this first chunk, and then I have this second chunk. So the first chunk here is as I'm approaching 2, but I'm coming at it from the left-hand side here. Whereas the second one is I'm approaching 2, but I'd be coming at it from the right-hand side. So technically, we would write this as 2 with the little plus, because I'm coming from the positive side from the right-hand side. And the negative is saying I'm coming from the left-hand side. Does that help explain it? No problem. Okay, for 7, it's a partial fraction, so you let a over x, because I wasn't sure how to break that apart further. When you get the a, b, and c, the a is easy, but the b and c are not. Okay. Whoops. Okay, so yeah. So 7 actually is interesting. You could do 7 one of 2 ways. You could either do partial fractions or you could do trig substitution, but you definitely can do partial fractions. So if you do in 7, okay, so you have the integral of 1 over x times x squared plus 4 dx, and then you should have, let me pull up what the answer is so that we can spend the time integrating, not doing the partial fraction part. So if you do partial fractions, you should end up with, so do partial fractions, and you should end up with the integral of 1/4 over x dx plus the integral of minus 1/4 x over x squared plus 4 dx. So basically, the way that I have it is my a ended up being 1/4, my b ended up being minus 1/4, and my c was 0. So is that what you got for your a, b, and c? So let's start there. I got the A, is that, but B and C. Oh, so yours was actually, your question was in breaking it up. How do you actually find B and C? I thought your question was in the integrating part. Okay, not a problem. All right, so then let's do that partial fraction part. So I have 1 over x times x squared plus 4. I'm sorry, I didn't realize which part you were stuck on. Okay, so we have A over x plus bx plus c over x squared plus 4, right? That's how you started to set it up? Okay, and then we multiply everything by x times x squared plus 4. And so on the first piece, we'd just be left with 1. And then we're going to have a times x squared plus 4 plus bx plus c times x, right? Okay, and then I'm assuming you let x be equal to 0 to figure out what a is. Okay, yep. So 1 is going to be equal to a times 0 plus 4 plus b times 0 plus c times 0. So all of this stuff here is 0. So that's how we get 1 is equal to 4a. A is equal to 1/4. And you're like, yeah, that was the easy part. So then what did you do after that? It's okay, but what did you try to do? Okay, so you plugged in a. So plugging in a is fine. So 1 is going to be equal to 1/4 times x squared plus 4 plus bx plus c times x. Okay, then what did you do? Okay, totally fine. So 1 is equal to 1/4 x squared plus 1 plus bx squared plus cx. Right? We okay with that? Okay. So are you okay with what I did so far then? Okay. So what I would do past this step is I would put the pieces together. So if you notice, I have two x squared terms, right? So 1 is going to be equal to, so my x squared stuff is 1/4 x squared plus bx squared. And then my x term is just the cx, and then I have the plus 1. So on this side, right, so in this first piece here, I can factor out an x squared. So 1 is equal to, we're going to have x squared times 1/4 plus b plus cx plus 1. Does that make sense so far? Okay, so now if you notice, on this side I have an x squared, but over on this side I don't have any x squareds. So what that means is that this 1/4 plus b has to turn out to be equal to 0, which would mean that b has to be minus 1/4. Cx, so on this side I have an x, but on this side there are no x's. So that's what's telling me that, oh, c has to turn out to be equal to 0 because because otherwise I'm like, I would have an x on the right hand side, but no x's on the left hand side. So yeah, so one of the things you want to try to do, if you're going to put stuff in and multiply it out, then you want to group the like terms together and you're matching coefficients from the left side to the right side, right? So essentially what I'm matching is, I didn't write it over here, but it's like I have 0x squared plus 0x plus 1. So this 0 here has to match up with the 1/4 plus b. This 0 here has to match up with the c, and then this 1 here has to match up with the 1 there, which it does. No problem. Other questions? And that was actually, like, I did it on the review, or on the answers. I just picked 2 other x values and got 2 other equations that had b and c in them and then solved those. But this way, it's probably like, either way, it's probably roughly about the same amount of work. This way might actually be a little faster in this problem. Number 8, I got up to the point where you change the x's to thetas, and then I got 9 sine squared theta d theta, and I didn't know how to get it further. Yeah, so, okay, so if you want to integrate the sine squared theta, that's when you're going to use the half, well, there's a couple things you could do. You could use the half angle identity, or you could replace sine squared theta. So you want to use the half angle identity to replace sine squared theta. So remember, we have the integral. So if you were at the integral of 9 sine squared theta d theta, right, you could factor the 9 out, and you'd have 9 times the integral of sine squared theta d theta. And then you would want to replace sine squared theta with the half angle identity. So it's 1/2 1 minus the cosine of 2 theta d theta. So, and then now you can integrate each of those pieces. However, if you look at the original problem in 9, so the integral from 0 to 2 of x over the square root of 4 plus x squared dx, yes, you can totally do the trig substitution, and it's long, and it will get you to the right answer eventually, or you can realize that I could have just done regular old u substitution on this problem. So if I let u be 4 plus x squared, du would end up being 2x dx. So I need a 2 balanced with a 1/2. So this is going to be 1/2. We'll take care of the things, the limits of integrations first. In a minute. And I end up with 1 over the square root of u du, right? And then I could change the limits, so when x equals 2, u is going to be 4 plus 2 squared, or 8. So my top limit here is going to be 8. And when x equals 0, u is going to be 4 plus 0 squared, or 4. And so, yeah, now you have this nice little problem, which is the integral from 4 to 8 of u to the minus 1/2 du. So you get 1/2 u to the 1/2 over 1/2 evaluated from 4 to 8. Your 2's cancel out, so you just have square root of u evaluated from 4 to 8. So it's square root of 8 minus square root of 4, or square root of 8 minus 2. So you can definitely do the trig substitution, but it's going to give you a way, way uglier, messier problem to deal with, and your answer is going to have an inverse, your answer is going to have an inverse trig function in it. How did I change? Oh, so, you're saying here, how did I change the x squared into 2x here?
This is easier. Just explain.
Yeah.
So the initial problem was, let's see, it was the integral of x squared over the square root of 9 minus x squared.
Oh, wait. I went to the wrong... Oh, I went to the wrong problem. Sorry. Yeah, I skipped. You're right. This is an 8. This one I just did is 9. You're right. Yeah, you're right. You can't. So 8 is a different problem, and 8 you want to do what I did up here. Sorry about that.
No worries. I was confused.
No. Yeah, no, that was my fault. I'm sorry. Yeah. 9, you don't need to do trig substitution. You could do trig substitution down here, but you don't need to. 8, you do.
So on 8, you need to do the trig substitution.
Yeah, 8, you do need to do the trig substitution, and you will get to
Okay.
9. Sorry, yeah, you will get to a 9 sine squared theta, which then becomes then you have this 9. Then you can rewrite sine squared theta as 1/2 1 minus cosine of 2 theta.
Okay, yeah, I was wondering about 8 too, but this is the half angle identities.
Yeah, you have to use the half angle identity.
Thank you.
No problem. Sorry about that. Yeah, so for 8, I would pull the 1/2 out. So you end up with 9/2 the integral of 1 minus the cosine of 2 theta d theta. And then this is going to be 9/2 theta minus, or 9/2 times theta minus, the integral here is going to be 1/2 the sine of 2 theta plus c. Okay, so how do you find theta? All right, so let me, since I ran out of room here, let me select this. Oops. Yeah. Let me select it in a little bit nicer of a fashion so I get everything we need here. Okay, so let me go here to this page. Okay, so you've done a bunch of work from the original problem, right? So the original problem was x squared over square root of 9 minus x squared dx. And then the thing here is that I should have left myself more room here. Okay, so when you did the trig, right, you would have made the substitution that x is equal to 3 sine theta, right? Which is telling you, if you divide both sides by 3, that the sine of theta is equal to x over 3, and that would allow you to draw your triangle, right? So here's theta. The sine is opposite x over the hypotenuse 3, and then if you do Pythagorean theorem, this side works out to be 9 minus x squared. So now I have this. Now you've, like, once you've done all your substituting and then you're integrating and stuff, you're down at this point, right? And so we're going to need to use the triangle to get this stuff. So a couple things. One is my triangle is in terms of theta and not 2 theta. So the first thing I need to do is I need to think of this. This is 9/2 theta minus 1/2. Sine of 2 theta is 2 sine theta cosine theta plus c. So we have 9/2 theta minus sine theta cosine theta plus c. So sine theta and cosine theta, I can now read off the triangle. To get theta, I have to take the inverse. So I know that x over 3 is equal to the sine of theta. And what that means is that the inverse sine of x over 3 would give me theta. So your final answer is going to have an inverse function in it. So it's going to be 9/2 inverse sine of x over 3 minus the sine, which would be x over 3, the cosine square root of 9 minus x squared all over 3 plus c. Yeah, the little theta is a little tricky. Does that help, though, with it? No problem. Okay, so I will post the solutions to this. I will go do that right now before I even go to my office hours. Because I just have to, like, do 2 clicks to get them up there for you guys. And then Thursday we'll review. So if you have any questions or any other the problems, or you see more of these problems you want me to do on Thursday, I can totally do that. So that's kind of the end of that, and I'll see you guys all on Thursday.